Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Let's say your team is responsible for configuring the backend services for an HTTP/HTTPS load balancer, which has a managed instance group as the backend. The servers are located in London, but users are expected to connect to the application globally. Which of the following services provides a cost-effective way to increase performance and lower latency for users by reducing the traffic going to the instances? Option 1. Turn on caching on the HTTP/HTTPS load balancer. Option 2. Turn on Cloud CDN to cache information closer to users. Option 3. Create managed instance groups in various regions and attach them to the HTTP/HTTPS load balancing. Option 4. Use Cloud Armor policies to allow traffic from all IP addresses globally. Slide 2. Identifying the correct solution. Now that we've heard the question, let's analyze the options and find the best fit. The correct answer is the second one. Turn on Cloud CDN to cache information closer to users. This is the right choice because it directly addresses all parts of the question. A content delivery network, or CDN, is a global network of servers specifically designed to solve this exact problem. By caching, or storing, copies of your content on servers all around the world, it dramatically improves performance and lowers latency for your users. And because many user requests are served from these global cache servers, it significantly reduces the amount of traffic that needs to travel all the way to your origin servers in London. This makes it a very cost-effective solution for serving a global audience from a single location. To understand why a CDN is so important, we have to understand the enemy: latency. Latency is the time it takes for a piece of data to travel from a source to a destination. In our scenario, our servers are in London. When a user in Sydney, Australia, wants to access our application, their request has to travel halfway around the world to London. Then, our server's response has to travel all the way back to Sydney. This round trip takes time, and that delay is latency. For a global application, especially a game, high latency can make the service feel slow, unresponsive, and frustrating for users. The diagram on the slide clearly shows this problem. Every single user, no matter where they are, has to make the long trip to our single backend location in London. This is not only slow for distant users but also puts a huge strain on our London servers, which have to handle every single request from the entire world. So how do we fight latency? We use a content delivery network, or CDN. Think of it like a global chain of convenience stores. Instead of having just one giant supermarket in London, our origin server, we open up thousands of small stores all over the world. These small stores are Google's Edge cache servers. When a user in Sydney requests something from our website, like an image, for the very first time, the request goes to the convenience store, the Edge cache, in Sydney. The store doesn't have it yet, so it makes one trip to the main supermarket in London to get it. But then, it keeps a copy of that image in the Sydney store. Now, when the next user in Sydney asks for the same image, the local store can just give it to them instantly. The request never has to travel to London. This is caching. By serving content from a location that is physically closer to the user, we dramatically reduce latency and improve performance. Cloud CDN, and the Global Load Balancer. In Google Cloud, the CDN service is called Cloud CDN, and it integrates perfectly with the global HTTP/HTTPS load balancer. You don't have to manage a separate service. You just enable it on your load balancer's backend configuration. Once you enable it, the process is seamless. When a request comes in, it hits the load balancer first. The load balancer checks if the requested content is available in a nearby Edge cache and if it's still fresh and hasn't expired. If the answer is yes, we have what's called a cache hit. The content is served directly from the edge, which is incredibly fast. The request never even touches your servers in London. If the content isn't in the cache or has expired, a cache miss, only then does the load balancer forward the request to your origin servers in London. This process of serving content from the cache is what directly fulfills the requirement of reducing the traffic going to the instances. Let's analyze the other options to see why they are less suitable. The first option, turning on caching on the HTTP/HTTPS load balancer, is technically what Cloud CDN does, but the second option is more specific and accurate. Cloud CDN is the name of the service that provides the caching functionality for the load balancer. So, the second option is a better description. The third option, creating managed instance groups in various regions, would certainly improve performance, but it fails the cost-effective part of the question. Running full copies of your application in multiple regions is the most expensive way to solve this problem. It's a valid strategy for some use cases, but it's not the most cost-effective way to handle static content. The last option, Cloud Armor policies, is completely wrong. Cloud Armor is a security product, like a web application firewall, or WAF. It's used to protect your application from attacks like DDoS or SQL injection. It has nothing to do with performance, latency, or caching. Enabling Cloud CDN is remarkably simple. It's not a separate resource you create, but rather a feature you enable on an existing backend service or backend bucket that is attached to your load balancer. The command is gcloud compute backend services update. You provide the name of your backend service, for example, my web backend. The global flag is important because you are modifying a global load balancer resource. And then, the magic happens with one simple flag: enable CDN. That's it. Once you run this command, Google Cloud automatically starts using its global network of edge caches for any cacheable content served by that backend. You can further customize the caching behavior, such as setting the cache TTL, or time to live, but just enabling it is all you need to do to get started and see a massive improvement in global performance. Thank you for your attendance. Please consider subscribing to the channel.